Hello again and welcome to video lecture number 5, which covers section 0.4, Algebra 1 Review, Properties of Real Numbers and Absolute Value. As always, please take a moment to read today's objectives. Objective number 1 in this video lecture relates to the properties of real numbers and being able to know what they really mean. The first property of real numbers that will follow is the commutative property of addition. Now typically words like commutative scare students. However, if you look in the description column, that's where we'll try to put it in more student-friendly language. So the description I have of this property is simply that when you add things, numbers, variables, the order in which you do so does not matter. So then if you take a look at the example, you'll see what I mean even further. For instance, 2 plus 4 plus 5, or 11, is the same thing as 5 plus 2 plus 4, which is also 11. So you could add the 5 and the 2 first, or you could add the 4 and the 5 first. It does not matter which order you go in. So when you see the word commutative, think order. And again, order does not matter. Just like addition, it doesn't matter the order. The same can be said about multiplication. Once again, it does not matter the order. So if you take a look at the example, -7 times 3 times 5 will give you the same exact result if you were to multiply 3 times 5 times -7. And these can be arranged even further and you'll still get the same answer. The next two properties deal with addition and multiplication, and they're called the associative properties. Now, in student-friendly language, associative simply means grouping. So when you see that word, think grouping, and how we group things in math are with parentheses. So simply put, it doesn't matter how you group or what you put in parentheses, you will still get the same answer. If you take a look at the examples in red and blue, hopefully you realize that in this case, I would do 4 plus 5 first because it's in parentheses according to the order of operations, and that would give me 9. Then I would do 2 plus 9, and I would get 11. Well, in this case, I would add 2 and 4 first, according to the parentheses and order of operations, and I would get 6. Then the 6 plus the 5 also gives me 11. So, as you can see, with addition and multiplication, it does not matter where those parentheses are. You will end up getting the same answer regardless. The next is probably the one you're most familiar with, and we call this the distributive property. And unlike the others, I'm not going to put any words in the description column. Rather, I have an arrow here just meaning copy those symbols down and you should be good. I will add these arrows. This tends to help people. Remember, the distributive property is asking us to multiply what's outside by everything that's inside. And so I've shown you an example on the right of how that works. The next two properties are called the additive and multiplicative identity properties. Simply put, with the additive identity, if you add 0 to any number, that number will not change. It remains the same, as you can see in the example. I started with -12, I add 0, I end with -12. With multiplication, the identity is not 0, it's 1. Anytime you multiply by 1, the number will remain the same. Notice we start with 5, we end with 5. The key with identity is, remember, identity meaning stay the same. So a number will stay the same when added to 0, and a number will stay the same when multiplied by 1. The final two identities are the inverse properties, and we'll start with the additive inverse property. If you look at the symbols here, it gives you a pretty good explanation. In words, any number added to its opposite is 0. Notice 14 has an opposite, and its opposite is -14. When you add those two numbers together, you will always get 0. With the multiplicative inverse, anytime you take a number times its reciprocal, not its opposite, its reciprocal, notice 17 over 1, when I flip it, is 1 over 17. When you multiply those two things together, you will always get 1. Example 1 then asks us to take the properties we just described and wrote their definitions down and use them as answers to the following examples. So I'm going to do a few of these, and the rest you should try on your own and be ready to check for tomorrow. Let's start with B. Notice the first thing I see are these parentheses. Anytime I see parentheses, I'm going to think grouping. And anytime I say grouping, if you look back, we're going to think the associative property. And then it just becomes, is it associative property of addition or is it the associative property of multiplication? Well, clearly there's only multiplication. So our answer here is going to be the associative property, and I'm abbreviating here, of multiplication. Make sure you include whether it's addition or multiplication in the problem. The next example I'll try is 1G, and I look at these and I notice I'm adding opposites, right? So if we're adding opposite values together and we get 0, if you recall from your notes we just took down, this is what we call the additive inverse property, and of course I'm abbreviating. So go ahead and take a look back on the previous page if you have any questions. Please try the remaining problems for example 1 right now. Example 2 deals specifically with the commutative property, and as opposed to applying it to numbers, we're going to apply it to some common everyday scenarios. Now notice, if we write commutative as our answer, we are implying that the order in which you do these things does not matter. And if we say not commutative, we mean that the order in which you do things does matter. So I'm going to try one of these, and I'd like you to try the other 3 on your own. I'm going to start with example 2B. The scenario is washing your hair and washing your face. So we have 2 events going on, and the question is, could we do those in either order and still get the same result? Well, clearly, it doesn't matter which order I wash my hair or my face in, I'm still going to end up getting clean, right? So this would be a commutative property, and we would say as our explanation, either in any order. So we are free to wash our hair and our face in any order we want. So please try examples 2A, C, and D and have those ready to go for tomorrow. Part 2 of our notes is associated with objective number 2, knowing how to simplify expressions containing absolute value. Let's start with the definition. Absolute value is defined to be how far a number is from 0 on a number line. And recall, distances that we measure are always positive. So you're never going to get a negative answer for an absolute value if there's only one number inside. And we'll look at some other cases. Before we look at a few examples, remember the symbol for absolute value is 2 vertical bars with a value inside of it. That's the indication that we're looking for absolute value. So let's take a look at these 3 quick examples in the box. It says, what is the absolute value of -3? Well, simply put, how far is -3 from 0? Well, we know that that's a distance of 3, hence our answer is positive. For the absolute value of 3, we look, well, how far is 3 away from 0? And clearly that answer is 3 as well. The next case, what is the absolute value of 0? Well, how far is 0 from itself? Well, it is 0 units away. So hopefully that gives you a general idea of the concept of absolute value. Now let's apply it to some examples. Example 3 asks us to simplify each absolute value expression completely. And notice we're going to have to deal with the order of operations again. And what you need to do is treat that absolute value symbol as if it were parentheses, meaning do them first, right? Because in the order of operations, we always are going to take care of the parentheses first. So let's just start in no particular order with letter D. If I'm looking at letter D, I want to do what's inside the parentheses first. Well, unlike parentheses, however, remember absolute value turns numbers inside of them positive. So this becomes +6, We carry down the negative sign that is not inside the absolute value. We make negative 3 a positive 3. We carry down the positive symbol, and then we're going to do what's inside those parentheses, or absolute value symbol, and we get 17. We must turn that positive according to absolute value, and then we get this expression. Now remember, with order of operations, and when we only have addition and subtraction left, we are going to move left to right. So 6 minus 3 plus 17 gives us a final answer of 20. I'd like to show you one more exercise from example 3, and that would be F. Once again, I'll treat it just like the other problem. I'm going to look inside the absolute values as if they were parentheses to try and focus my attention there first. I'll look at this one. 9 plus 2 is 11. The absolute value of 11 is 11. I'll carry down any negative signs that are in between absolute value symbols. Negative 7 plus negative 3 is negative 10. However, the absolute value of that would make it a positive 10. I'll carry down this negative sign, and the absolute value of negative 4 is positive 4. So now what we're left with is 11 minus 10 minus 4, and we are going to move left to right. So what we end up getting is 11 minus 10 gives us 1, and then 1 minus 4 gives us negative 3. So please try any exercise from example 3 that I have not shown you in the video lecture. Finally, example 4 asks us to simplify absolute value expressions when there are variables. Well, at the top, you're given a number for each variable, so all we have to do is simply substitute those numbers in for the variables before we start simplifying. I've shown you that here on exercise 2 of example 4. So now that I've set it up, let's look inside the absolute value symbols as if they were parentheses, and we will do the order of operations within. So I'm going to multiply the 9 times negative 3 first and get negative 27, and now I have negative 27 minus a negative 10, still absolute value. Now the next thing I'm going to do is our good old friend same, change, change, and from there I'll add those two numbers together to get negative 17. However, because it's absolute value, my final answer is positive 17. So that wraps up video lecture number 5. I would like you to complete the rest of the exercises from example 4, and you can check those in class tomorrow. Also, please, at the bottom of this page, write down at least one question you still have after viewing the video. Thanks for taking the time to watch, and I'll see you in class tomorrow. Good luck.